Welcome, thanks for bearing with us. Okay, so today we are going to be talking about OpenStack and containers and Ceph, all right? So I'm Andrew, I'm from Brisbane, I'm actually local. I look after cloud storage and big data primarily, but broadly emerging technologies infrastructure at Red Hat. We have Federico Lucafredi, who is a product manager for Ceph based in Boston, and we have Sebastian Hahn, who is the guy that makes everything happen, right? So based in Paris. So we've got a little bit of a song and dance. For those of you who have been to OpenStack summits before, I'm filling in for Sean Cohen. I'm better looking, you can tell him that, that's fine. But he's funnier. So why are we doing this, right? So there's a number of reasons, a number of drivers. The first thing that containers deliver is a unified and standard packaging format. So it makes things really easy to distribute. For those that were in the session earlier around NFV, you don't need to worry about streaming images and things like that. Like, it's just a container, and it's easier to upgrade and downgrade them, especially once we start using Kubernetes as the underlying orchestrator to do that, right? So one of the challenges around day two operations with OpenStack, less so with Ceph, but especially at scale, it does become something you need to take into consideration, is how do we do upgrades and without disruption? So containers deliver a lot of benefit in doing that, right? It's also much more flexible. When we're using containers and something like Kubernetes, we can have, in some cases, more homogeneous hardware, and we can use labels to dictate where services run. So for those of you that are using OOO or Red Hat Director for deployment, we have these composable roles, and so that's great for when you're defining your infrastructure, and that produces a heat template and some Ansible playbooks. But that's only for day one, right? So when you're then wanting to go and maintain your system, I want to take a host out because it's failed, or I want to go and add new hardware or do a refresh, being able to dynamically position those without having to manually do it is a much more easier operational task. Certainly it's easier to scale rather than having to manage the configuration of every little role. When they're a container, it's already prepackaged and I can just set a replication count. Makes it easier to make them highly available as well. Because as a snap poll I did yesterday, everyone hates pacemaker and CoroSync except for the gentleman down in the corner. You can go and talk about pain with him later. Immutable infrastructure, certainly we don't necessarily want a lot of those services to change unless we're doing an upgrade. So containers, they don't change, right? So for those of you who are doing DevOps or container workloads today, you'd understand that when an image is instantiated into a container instance and then it's destroyed, any changes are gone and they're ephemeral. So that's really good for us. And then from a resource constraints perspective, this is where we're able to take advantage of things like Hyperconvergence or CPU pinning, NUMA, etc., and get better utilization out of the hardware because we can set resource governance limits. And obviously speed, speed in execution and speed in operations. So this is where all of that is being delivered in part by Kubernetes. So Kubernetes has won the container orchestration war. Even the companies that were behind that have capitulated, and everyone is now backing Kubernetes. If you're doing something else, you're doing what the community is not moving towards. All right, so it's self-healing, it's got load balancing, it's very mature around its concept of instances, routes, services, resources, being able to label resources and hosts. So Kubernetes is kind of like that data center operating orchestration system for a cloud, right? Whether that's on-premise or in a public cloud. And it allows this pluggable architecture for whether it's networks or DevOps tool chains or storage, etc. Right? So the concept of storage within Kubernetes is rapidly maturing, but it's a fairly simple concept as it is today, right? So we have this idea of persistent volumes, which is, as it sounds, it's a volume that you store persistent data in, and it points somewhere. And there's a number of drivers. So we could use something like a legacy system like iSCSI. We could use NFS if you're feeling so inclined. But from an OpenStack and certainly with Ceph perspective, we want to use RBD and shortly CephFS, right? So the CephFS piece is coming imminently, but today we can certainly do RBD, right? So we can have a pod, it might be a controller service, for example, running that needs some persistent storage, right? And then we have this concept of a claim. So, in a DevOps world, that would be a developer. In an OpenStack world, that's an operator, right? Typically, right? And then the way in which that piece works is we have this concept of storage classes. So we define the characteristics of the storage and how it behaves underneath. So we've got slow Azure Disk, we've got semi-fast Amazon, and then we've got super blazing fast. This is the interactive bit. Ceph, right? Right, they'll wake up for you guys later. Okay? And then the operator or the user creates a claim, said, hey, look, I want that, and then Kubernetes creates it binds that claim to that storage persistent volume, right? Federico.
No, still you.
No, it's still me. Okay, right. So why OpenStack on Kubernetes, right? So certainly things like ease of deployment, right? It makes life a lot easier to deploy OpenStack services on an orchestratable platform that is self-healing and scales itself, right? So who has not used Kubernetes or OpenShift? All right, okay, so now here's your homework. Right? It is really good, right? It makes life a lot easier, especially if you're a developer, right? So it makes a lot of sense to leverage something that is already highly mature. Like Kubernetes came from Google, where they run billions of containers a day, right? They know how to do data center orchestration at scale, right? So rather than having to worry about doing days or hours, I can now go and deploy whole clouds in minutes, and life is a lot easier. And then scheduling between Nova and Kubernetes. So a little bit of background, there was the Collar project that Red Hat helped incubate, and then that was all around running OpenStack services in a container, right? And then being able to leverage Kubernetes to go and take that further. So for those that, this is a little confusing, there's the Magnum project, which is around orchestrating container workloads, and then there's Collar, which is about running controller services as containers, so that they are different, right? There are others out there, but Kubernetes has won. That's what the community has chosen, right? So from a Collar perspective, zooming, it solves the manageability and availability problem. So especially on those services that require pacemaker, you're limited to the same L2 domain. It's challenging to configure unless you're masochistic. I'm going to pick on you all week, man. And it's easy to configure, right? So we can use heat templates and YAML to go and deploy that. Then there's Ansible container. It just makes life a lot easier. And then because containers, they're immutable, I can do atomic upgrades. So for those of you who have used Red Hat Atomic or a similar Linux spin, where similar to when you update your phone, right? Like you don't do in-place upgrades of your operating system, you get a whole new image, and then you've got a copy somewhere, and you reboot, and the new one is there, right? So it makes blue-green deployments a lot easier. Because if it breaks, I just turn it off and go back to the old version. There's no managing about dependencies or interoperability, right? And then we have, I love open source and the names we come up with. So Courier and Foxy. So again, for those that are familiar with Kubernetes, it has its own software-defined network, right? It might be Calico, it might be Flannel, and then in OpenStack, you've got Neutron for your SDN, right? And that might be, it stays within OpenStack, or it might be you're talking to an external, third-party SDN controller, right? But they're different networks. So what Courier does is allow, when you create a storage claim, it matches up the network at the software-defined networking layer between OpenStack and Kubernetes. So you get that same network all the way through. So as you'll see later, and as I touched on a little bit yesterday, when we run Ceph clusters in Kubernetes, that gives us a lot of flexibility and is able to separate our network traffic from front and back, public or storage, right? And then Foxy is a way to leverage existing storage driver efforts rather than having to write everything again. Because Kubernetes is a different framework, and we've already got a list of Cinder drivers as long as our arm, although we only need one, right? So that's a way that we can reuse existing effort. Now it's Federico.
Thank you, sir. So let's look at how Ceph looks like in containers. Cola coverage for containers. So all the projects are covered, of course. And then some options are available for Ceph. The very straightforward 3-node default configuration is available. It's not big in scale, going to the question that we had earlier, but it's a valid Ceph configuration, fully supportable. Then there is the developer configuration, which is everything in one node. That is obviously very low resiliency and not a supportable configuration, but it can be convenient when you're writing code. And there is a third option, which is to import an external Ceph cluster that's located on other nodes. So a couple more considerations. One is Cola. I think that Cola doesn't get enough credit in the community when you see data about how much it's used. And generally, as a product manager, when I ask of people, are you using Cola? I get the answer, no. But then when I talk to the people that are doing containers, I ask them, where does the code for your containers come from? And the answer is always Cola. So there is an undercurrent of people that are not using all of Cola, but they are liberally borrowing the code to build the templates. So it's more popular than what you would believe if you just look at the stats. That's one thing. Another thing is, we pointed out last year that there was sort of duplication, that Cola used its own playbooks to generate Ceph images, and that probably there was a possibility to converge things further. And yesterday I learned that in future versions of Cola, we're going to start pulling images from the Ceph container project. So see, open source works. So what is the Ceph container project? A Ceph container project is the source of all Ceph containers. You could think of it that way. It is surprisingly popular as an infrastructure project. You can see that it has more than 5 million pulls from Docker Hub, which is kind of crazy. This is a 3-year-old project started by Sebastian, but since he is the modest kind, I will do the bragging for him. It's been almost 3 years, so it has seen quite a bit of use, and it's fairly robust. And it is not only what you get when you do Docker pull Ceph. This is what you get out of that. It is also the basis for what you get when you are a Red Hat customer and you get either our tech preview or supported container. It's been tech preview for a couple of years, and since June, there's been a supported version of our downstream supported bits in container format. That it also derives from here. So this is really the origin of all Ceph containers. It supports all major operating systems, for OpenStack anyway, and it's up to date to the latest Ceph Luminous. So how does this work? Ceph container is a single image. So you Docker pull this image, and then Ceph has actually 8 daemons in the current version. So to choose what daemon you're instantiating out of the image, you pass environment parameters to Docker run. So Docker run the image name, and then all of the environment parameters. And so you can ask for an OSD, ask for a monitor, and so on. I'm not going to go over all the Ceph daemons. You probably know them already if you're in this session, but there are a few newer ones, more esoteric ones that have more recently appeared on the list. So there is an NFS gateway that's now become supported, where you can mount an RGW bucket as if it was an NFS directory for bulk import and export of data, and that is also supported in container hosted format. There is RBD Mirror, which is our asynchronous facility to carry image data between clusters for disaster recovery configurations. And there is also iSCSI, which is not containerized yet, but will be soon. Besides choosing what daemon you're instantiating with a specific container instance, you're also passing configuration options, such as where do you want, how do you want the journals to be? co-located or dedicated device. You can indicate that you want to use dmcrypt to encrypt the OSDs. You can select file store, which is a supported default today, or use BlueStore for trying the latest and greatest and soon to be supported faster backend. Or if you're setting up the Ceph infrastructure, the OSD, using alternate code, you can point to the directory where the OSD is already set up. Just give a path, and nothing will be touched. We'll just consume what is present at that directory. Ceph Ansible is presently our preferred deployment mode, where instead of using RPMs, you can choose to use container images. And the other part of the management-orchestration stack, in this case, is systemd, that acts as a watchdog and looks at the containers, and in case one dies, it respawns it so that you're not missing a piece of your infrastructure. This is a very flat deployment topology. Your daemons are located precisely on a given machine, and they will always be on that machine. It's not a container cluster. It's more of a collection of container hosts. And we're going to see how that evolves. It is evolving going towards Kubernetes. And the first bit in this is the Ceph Helm project. I like to think of Helm as a package manager for Kubernetes. And the charts, which is what their manifests are called, are available, the official ones from upstream, under the Ceph Helm project. That will give you a way to deploy a containerized Ceph cluster in Kubernetes, and it is very much in active development right now. So Andrew went over this already. These are the abstractions that Kubernetes provides for persistent storage. So you have persistent volume, which is very self-describing. The volume claim, which is a reference to this volume, and the storage class, which you can think of as a driver. If you, in your Kubernetes YAML code, replace the reference to a claim with a reference to a storage class that's being initialized, you get dynamic provisioning, which means that volumes that do not exist get created on the fly and attached to your claim, so you don't have to pre-provision them. Today, Ceph supports CephRBD and Cinder storage classes. And as Andrew was saying, the future will include CephFS and Manila storage classes support as well. So now I'll hand it over to Sebastian to see how all of these OpenStack, Ceph containerized pieces fit all together. But before we go there, we have one more thing.
The famous one more thing. So now I'm gonna present a little project that I worked on for the last week, I guess. It's called Ceph Nano. It's a little program that I wrote that is meant to ease the user experience when you're a developer and when you don't know anything about Ceph and you just don't know how to deploy it or anything, but you're a developer and you have to connect your own application to Ceph. So it's the one-step S3 application that will definitely help you build your own application. So as Federico mentioned, we have Ceph images. We have one Ceph image for containers, and we have several scenarios. As part of those scenarios, we have one that is called Demo. It's probably a bad name to call it, but it's just an all-in-one container that in the end will run all the Ceph daemons. And this is the scenario we are using when we deploy a Ceph Nano container. So basically what you would get is a little container that has all the Ceph daemons running. Then from that, we allow you to wrap some of the S3 commands from the CLI, so you can create buckets and things like this. So it's pretty new. It supports reboot, so I mean it's really handy when, as a developer, you just shut down your laptop and then you just resume again, and you can continue to work on your own application. So it's just a little program that we just launched like this week actually, and that is really really handy and should definitely ease the developer experience. So this is just a little demo, so you can just get a sense of what the program does. So as all the good projects, I guess we have a .io page on GitHub, and then what we do here is just curl the program, we just shmod it, so we make it executable, and then we just start the program. So basically in the background, what that does, it's we just kick off the container. So depending on your network and a lot of other things, this might take like up to 30 seconds just to get the container up and running, as you have to fetch the image. Then we have to bootstrap the initial container with all the Ceph daemons, and we have to configure them. So, well, it takes about 30 to 40 seconds to run, but will be definitely much quicker the next time you just run it. So once that's done, you get a little status on what's the health of Ceph, and also what's the URL of a Rados gateway, so the S3 interface, then you get your own credentials. So then what I was saying is that I just created a bucket, so it's just Ceph Nano make bucket, and then here I'm just going to sync one of my local directory into that bucket, so by using the wrapper commands. Then here I think I'm going to show the help, so you will see. No, I'm actually listing all the buckets and all the objects that are part of that bucket. So it's fairly easy to use, really easygoing experience. And this is, I'm going to try to post that really quick. But this is basically what you get once you ask for the help on that little program. So you can do all basic things like start, stop, restart, status. You can just purge everything if you're done with your work. And you can also has for the logs of your Rados gateway if you want, just to make sure that everything works properly. And then we have just a fairly just amount of like calls that are the most popular ones when you want to play with a Rados gateway interface. Obviously, if you are a programmer, then you can basically have a Python program and connect to your Rados gateway using the credentials that were shown when you do the Ceph Nano status. Oopsie. Okay, so now moving back a little bit on our architecture use cases when you're deploying your first OpenStack cloud with containerized services. So this is basically what you will get once you deploy the latest OpenStack version. Now, as everything is being containerized from Color images and also using the Ceph images that we provide, if you use Ceph backend, and which you should do actually. So in terms of infrastructure, this is pretty similar to what you will get eventually once we get to Kubernetes. So you have Kubernetes masters and all of their components. Then you will have OpenStack controllers. And as mentioned by Andrew, we can use Courier and Foxy either to connect the network PCs or the storage one. You will have your base container image, whether you want to use Docker or other container engines. And all of the little boxes are effectively containers that are just being, not say co-located, but just basically running on the same machine. So this, well, as an overview, this looks pretty similar to what you currently have. It's just the only difference is that now you have a container engine, and also all of your OpenStack services are basically running into containers. When you look at the compute piece, it's just VMs and also VMs who run into containers. So it's a little bit tricky, but then this is all we want to get a better isolation as well. As for Ceph, then we have always these daemons that are running within containers too. So yeah, pretty straightforward. If we do a little zoom in on what's hyperconvergence, this is definitely one of the use cases that is enabled by running when you run containers. This is something that is pretty difficult to achieve, not impossible when you don't do containers, but it's just that in terms of management, life cycle of application upgrades, or maybe rollbacks as well, this is something that you don't necessarily can easily do when you don't run containers. So it's a huge facilitator to run containers to do hyperconvergence. So hyperconvergence is just a really fancy word to explain that you collocate compute and storage services onto the same machine, which definitely helps you to get a better hardware utilization, and it's in the end it becomes really cost effective. So just as mentioned, this little zoom in, this is basically your hypervisor box. not sure if we should call it hypervisor box anymore because now we run storage too, but this is your hyperconverged box that contains all of your OpenStack VMs and also runs OSD services, which are the storage daemons from Ceph. We also obviously run the network piece for OpenStack, so VMs can just be connected to each other. So let's go back a little bit and give you a little understanding on how we should be deploying all of these containers. So we have different approaches at the moment. If you look at the latest OpenStack version, and if you use TripleO, obviously, to deploy your OpenStack environment, then from TripleO you can now trigger a containerized deployment. When it's without when it's with pure OpenStack services, that's going to get triggered by still Puppet, but then you run containers too. When it's with Ceph, we implemented something a little bit different. We used a Mistral project. It's a workflow project that allows us to trigger external deployment tools. So in our case, what we do is we create a Mistral workflow that's going to trigger Ceph Ansible to deploy your containerized Ceph cluster. So as of the latest release of OpenStack, you can deploy a containerized platform. But that's going to be a really static platform because there is no Kubernetes yet. It's planned, but it's, as mentioned by Federico, it's a really flat deployment. There is just an orchestration at the deployment level, but not at the lifecycle level. Obviously, Ansible, I briefly discussed that already, but this is what's being used in the background when we deploy Ceph as part of OpenStack now. And I believe some of the other OpenStack projects and also some of the new OpenStack projects will just move toward Ansible to deploy their containerized daemons. The Ansible is super easy to learn, but one of the drawbacks when it comes to a containerized platform is that we have this really flat deployment where we just have an inventory file with a couple of sections. This is a monitor, this is an OSD, this is an MDS. So there is no real intelligence, nothing really smart here. Yeah, that's the state of the art at the moment, and probably one of the best approaches that we can have to deploy containers if you don't go with Kubernetes or other container orchestrator. All of the containers are managed by systemd. So in terms of operations, the operational experience is kind of similar to what you used to have. You just use systemd to control your services. Then you use systemd to control your containers. But you might not be aware that these are containers in the background. So it's really handy. As for Kubernetes, this is definitely where everyone is moving toward to. And this is something we have been really heavily investing for the last couple of years now to get finally Kubernetes in a shape and a readiness that we want for OpenStack. But this is something that is not there yet. We're going to see that in a second. But things are really promising. I mean, in terms of Ceph and also OpenStack, one of the most difficult and the most challenging part is that some of the services in OpenStack are not stateless. So all of the stateful applications, they are really pinned to a particular server, and then they don't really move around when the host fails. So that's something a little bit tricky to manage, but that's something we're working on. And these are the challenges and basically the matrix, the table that we have to be compliant with if we want to go with Kubernetes on OpenStack. So I'm just going to skip with all the green lines, but something that is really important is the network isolation. As part of OpenStack, you might know that we have networks a little bit for everything, networks for API, for internal APIs, external APIs calls, networks for tenants, for storage, public storage, network storage, private storage, sorry, and maybe others as well. And as mentioned by Andrew already, within Kubernetes, we only allowed a single flat network namespace. So this is definitely something we don't really want to have because we can't really segregate different network flows. In terms of IPv6 support, this is currently work in progress. This is also something that we really want to enable because if we want to scale, or maybe if you're just a telco, then you really want to use IPv6 because your network is just full IPv6 already. Also, as part of the HA stack, we want to have a mechanism pod fencing. So the pod is definitely the entity that will be running all of your containers. Not all of your containers, but some of your labeled applications for OpenStack. And if it's a controller, for example, then we want to have the ability to fence a pod. If a machine is in a state that we just don't know the state of that machine, then we want to be able to fence that machine, so to force the shutdown of that machine. And this is not something that is currently available in Kubernetes, especially given that in OpenStack we run databases. So if there is a node that becomes master and then we get into a really inconsistent state, then we definitely want to have this fencing capability. So then what's next? And I think it's Federico's turn again to do a little roadmap on the containerized version of Ceph. You have one.
So we've seen what's done. The container is there. We've moved from tech preview to support, at least as far as the Red Hat distribution of Ceph is concerned. And there are now supported official images from the upstream project as well. That happened on the same day, surprisingly, this month. We are prototyping Kubernetes support in the Mimic cycle, and you have the link of some of the projects where this is happening. And as we mentioned before, Colla is switching to use Ceph container images, so we're eliminating the deduplication. Now, it's kind of hard to speak in abstract about this since it's integration that pertains to a specific Ceph distribution. So I apologize for the slight vendoritis here, but I need to use our product to point out where we are in our specific case, since not all Ceph distributions are in the same place. In 2016, we went to tech preview with the Docker container. In June, we went to support with the Docker container again, or more properly at that point, the Moby container. And that is the flat deployment, so no orchestration, just Ansible and systemd. With Red Hat Ceph Storage 3, which coincidentally is being announced today, we are introducing co-location support. So these containers can be placed on the same hosts. All the hosts are storage hosts now. There are 8 daemons in Ceph. 1 is storage. The other 7 are scale-out daemons. You can now co-locate these scale-out daemons with the storage ones, thanks to the fact that we can have a resource reservation for CPU and for RAM through the container abstraction. We're going to add support for the iSCSI gateway in the next point release. And we're working towards going to full support with Kubernetes in the next major release of Red Hat Ceph Storage, which is going to be next year. Seb?
Okay, so some of the key takeaways before we stop. So if you have something that you should remember going outside this talk is that we are currently iterating. I mean, we are doing really iteration phases when it comes to containers. We know it's really challenging, but we also know that everyone is moving toward using containers for everything on their platform. So we really have to start somewhere. So now the current implementation is not as dynamic as we want it, as we would like it to be, but that's why we use Ansible. But in the near future, we will definitely, as mentioned, we are really, we have been investing a lot into enabling Kubernetes to match with all the features that we request from an OpenStack deployment perspective. So this is definitely the future, and this is something we are currently working on. And hopefully next year we will have hopefully good news on that subject. But one of the most challenging part is definitely the network piece within Kubernetes, because there are so many CNI available, and it's difficult to decide which one you want to use, and also which one is going to give us the best isolation and the best support for all the networks we want to have. So I mean, this is a challenge, but software development shouldn't be stopped by like technical difficulties. So this is where we are moving on that matter. And yeah, that's it. So we started a little bit late, but I think we still have 2 minutes, so we will be happy to take questions. Thanks for your attention.
Thank you.
Yeah, that's the
Thank you.
yeah. Yeah. Any? Yeah. Hello. Yeah.
You mentioned isolating the network a few times. Is it about isolating the network traffic from the storage?
It's basically the ability to have one separate storage. Oh, the question was.
Yeah.
The question was, when you mentioned isolation for networks, what kind of isolation are you talking about? Is it control flow or is it pure isolation? The isolation I mentioned is you have always a specific network for every single flow within OpenStack. So for APIs, for tenants, for storage as well. So you really want to segregate those communications within a separate network namespace. And this cannot be done currently with Kubernetes. And this is something we do with OVS, for example, now when you use OpenStack. So that's one of the challenge we're facing at the moment. Yeah.
So you mentioned that Kubernetes is the future. It's just missing a couple of critical features. What is your vision for Kubernetes in OpenStack when those gaps are filled? And there are no gaps in Kubernetes. Will Kubernetes slowly absorb some of the OpenStack's market share, or will they coexist? What's your vision?
Okay, so the question is, at some point we will reach a state where Kubernetes has all the features that we are requesting, and when we reach that point, is Kubernetes going to take over OpenStack and basically swallow all of the OpenStack and maybe many other things? The answer is a little bit of yes, because what we are also trying to enable is to have the smart capabilities of Kubernetes in terms of scheduling. To be able also to schedule VMs natively and not using the scheduler for OpenStack. So this is a little bit of a side project, but yes, maybe at some point Kubernetes will take a little bit more and more importance and more work as well. Yeah, so it will be able to schedule both containers and VMs depending on your use case. But yeah.
Do you think that will reuse a significant part of OpenStack code base, or will it be a rewrite?
The thing is, Kubernetes has a really pluggable interface. So when you see with storage, with identity, with network, we have pieces that we can reuse and enable. So I don't think we're going to end up in a situation where we have to rewrite everything, but more leverage what's existing and just connect Kubernetes to what's already there. Thank you.
Just an easy way to orchestrate that. So there's always going to be the difference between infrastructure stuff with, say, virtual machines and what OpenStack provides, and the developer CI/CD pipelines that DevOps want. So they're still going to have different functions, but underlying the technology might be shared. Yeah. That's right.
Thank you. Perhaps you just can take the mic. Well, let's do it like this.
How does Ceph compare with GlusterFS as a container storage solution?
Does Gluster have, is Gluster being containerized as well?
Yeah, yes.
Yes,
it
Gluster
is.
has a containerized version.
Yeah, yeah, yes.
Container version.
So how does it compare with Ceph? I mean,
We generally don't use Gluster to support OpenStack storage.
not OpenStack. I mean, OpenShift.
Yeah, so for OpenShift,
Yeah.
most workloads would use container native storage, which is built on Gluster, right? Because most of those workloads are file-based, and you want read-write many, which is shared file. All right, so as we saw earlier, that we're adding CephFS functionality in, and is that going to be direct, or will it be through Manila?
It will be either. Both drivers will be available.
Yep. So the answer today is if you're doing OpenShift and you want persistent storage, it's CNS, absolutely. If you're doing OpenStack and you want storage, the answer is Ceph. Right. They do different things.
Okay, I think we're all out of time, sorry, but we can take questions outside.
Thanks, guys.
Thanks, everyone.